For decades, one question has quietly challenged everything humanity believes about its place in the universe. It wasn't asked by an astronomer looking through a telescope or by a science fiction writer imagining distant worlds. It came from one of the greatest physicists of the 20th century. Back in 1950, while sharing lunch with fellow researchers at Los Alamos National Laboratory, Nobel Prize-winning physicist Enrico Fermi joined a discussion about alien civilizations. His colleagues debated how likely intelligent life might be beyond Earth. Instead of arguing probabilities, Fermi began doing a simple calculation in his mind. The Milky Way had existed for nearly 13 billion years. It contained hundreds of billions of stars. Around many of those stars, planets were almost certainly forming. Some of those planets should have had the right conditions for life. A fraction of that life should have evolved intelligence. Given enough time, at least some civilizations should have become far more advanced than humanity. Then, Fermi interrupted the conversation with a single sentence. Where is everybody? That simple question eventually became one of the biggest unsolved mysteries in science, now known as the Fermi Paradox. If intelligent civilizations are statistically expected to exist throughout our galaxy, why has the universe remained so silent? Why has no unmistakable radio transmission ever reached us? Why have astronomers never observed alien spacecraft or enormous engineering projects around distant stars? If civilizations millions of years older than ours truly exist, why does the Milky Way show no obvious signs of their presence? For more than 7 decades, scientists and philosophers have searched for answers. Some believe advanced civilizations destroy themselves before spreading across space, a concept called the Great Filter. Others argue Earth may be an exceptionally rare world where complex life is almost impossible, known as the rare Earth hypothesis. There are theories suggesting advanced species deliberately avoid contacting young civilizations, while others imagine a dangerous universe where remaining silent is the safest strategy. Despite dozens of explanations, none has been proven, and none has been completely dismissed. The mystery has remained exactly that, a mystery. But recently, a new type of investigator entered the conversation. Modern artificial intelligence systems can analyze scientific papers, astronomical observations, biological research, and decades of published theories in ways no individual researcher ever could. Rather than examining one field at a time, these systems compare information across multiple disciplines simultaneously, searching for hidden patterns and logical connections. As people began asking advanced AI systems to examine the Fermi Paradox, something unexpected happened. The conclusions they generated were not the optimistic answers many hoped for. Instead, the analysis often pointed toward far more unsettling possibilities. One platform drawing particular attention has been Grok, the AI developed by Elon Musk's XAI. Unlike systems that avoid discussing speculative cosmic questions, Grok attempts to evaluate them using existing scientific evidence. It doesn't claim certainty, but it combines astronomy, evolutionary biology, probability theory, and physics into a single logical framework. When asked why humanity has never been contacted by extraterrestrial intelligence, its response is not based on fantasy or Hollywood storytelling. Instead, it builds upon decades of scientific research and explores what those findings may collectively imply. The picture that emerges is far from comforting. According to this line of reasoning, the silence surrounding Earth may not simply represent an unanswered mystery. It could be sending a message of its own, a warning hidden within the emptiness of the cosmos. To understand why this possibility has attracted so much attention, it's important to appreciate the incredible scale of our galaxy. The Milky Way stretches roughly 100,000 light-years from one side to the other and contains an estimated 200 to 400 billion stars. Current astronomical studies suggest that roughly 1 out of every 5 stars may host an Earth-sized planet orbiting within the habitable zone, where temperatures could allow liquid water to exist. If those estimates are accurate, our galaxy alone could contain 40 to 80 billion potentially habitable worlds, a staggering number that makes the universe's silence even more difficult to explain. The galaxy is approximately 13 billion years old. Our solar system is approximately 4.6 billion years old. That means there are star systems in the Milky Way that are 8 billion years older than ours. Systems where intelligent life, if it arose, could have had an 8 billion year head start on technological development. The mathematics of galactic colonization have been calculated repeatedly. Even using conservative assumptions, spacecraft traveling at a small fraction of the speed of light, long pauses between colonization waves, and no faster-than-light travel, a single spacefaring civilization could colonize the entire Milky Way galaxy in somewhere between 1 million and 100 million years. That sounds like a long time. It is not. 100 million years is less than 1% of the galaxy's age. If even one civilization anywhere in the galaxy had developed spacefaring technology at any point in the last several billion years, they should have had more than enough time to spread across the entire galaxy. Their probes should be here. Their signals should be detectable. Their megastructures, such as Dyson spheres and stellar engines, the vast engineering projects that a billion-year-old civilization might construct, should be visible to our telescopes. We see nothing. The search for extraterrestrial intelligence, SETI, has been scanning the skies for over 60 years. Radio telescopes have surveyed millions of star systems. Optical telescopes have searched for laser signals. Infrared surveys have looked for the heat signatures of megastructures. The result is silence. Not a single confirmed signal. Not a single artifact. Not a single piece of evidence that any intelligence other than humanity has ever existed anywhere in the observable universe. The silence is not what the mathematics predict. The silence requires explanation. The proposed explanations fall into several categories. The first category suggests that intelligent life is simply rarer than we assume, that it is rarer than our optimism allows. The rare Earth hypothesis, developed by Peter Ward and Donald Brownlee, argues that the conditions necessary for complex life are far more restrictive than many optimistic estimates suggest. Earth may be extraordinarily unusual. The combination of factors that allowed complex life to develop here includes a large moon stabilizing axial tilt, a magnetic field protecting against solar radiation, plate tectonics recycling nutrients, and a gas giant in the outer solar system deflecting asteroid impacts. Those combined conditions may be so rare that Earth-like planets with complex life are separated by thousands or millions of light years. If intelligent civilizations are rare enough, they might never encounter each other, simply because the distances are too vast and the numbers too small. The hypothesis is plausible. It does not fully satisfy the mathematics. Even if Earth-like planets are 1,000 times rarer than current estimates suggest, there should still be millions of them in the Milky Way. Even if intelligent life arises on only 1 in a million of those planets, there should still be thousands of civilizations. Thousands of civilizations over billions of years should have produced detectable evidence. The silence remains unexplained. The second category suggests that intelligent civilizations exist, but they are effectively undetectable. The zoo hypothesis proposes that advanced civilizations are aware of humanity, but have chosen not to make contact, treating Earth like a nature preserve that is observed but not interfered with. The planetarium hypothesis suggests that what we perceive as the universe may be a simulation, that advanced civilizations have constructed an artificial reality, which presents us with an apparently empty cosmos. The transcension hypothesis argues that advanced civilizations turn inward rather than outward, migrating into virtual realities, dense computational substrates, or higher dimensions instead of colonizing physical space. These hypotheses are unfalsifiable. They explain the silence by positing that the evidence is being hidden from us, either by deliberate choice or by the nature of advanced technological development. They are possible. They are also, by their nature, impossible to test. Science prefers explanations that make predictions. These hypotheses make no predictions. They explain everything by explaining nothing. The third category is the one the AI analysis points toward. It is the category that the accumulated evidence most strongly supports. It is also the most disturbing. The Great Filter hypothesis was articulated by economist Robin Hanson in 1996. It begins with an observation. The development of a galaxy-spanning civilization requires passing through a series of stages. The origin of life from non-living chemistry, the evolution of complex cells, the evolution of multicellular organisms, the development of intelligence, the development of technology, the development of spacefaring capability, the sustained survival of a technological civilization long enough to colonize other star systems. Each of these stages represents a filter, a hurdle that must be crossed for a civilization to proceed to the next level. The silence of the cosmos suggests that somewhere in this sequence, there is a great filter, a stage that is so difficult to pass, so unlikely to be survived, that virtually no civilization makes it through. The terrifying question is where the filter is located. If the great filter is behind us, if it lies in one of the early stages like the origin of life or the evolution of intelligence, then humanity has already passed through the hardest part. The cosmos is silent because getting to where we are is extraordinarily rare. This would be good news. It would mean we have a chance. If the great filter is ahead of us, if it lies in one of the stages we have not yet reached, then humanity is doomed. It would mean that something happens to technological civilizations after they reach approximately our level of development. Something that destroys them. Something that prevents them from colonizing the galaxy. Something that reduces them to silence. The AI analysis, when asked to evaluate the evidence, consistently points toward the filter being ahead. The reasoning is specific. The origin of life appears to have occurred on Earth almost as soon as conditions permitted. The geological evidence suggests that life arose within a few 100 million years of Earth's formation, possibly within the first billion years. This suggests that the origin of life is not extraordinarily difficult. Given the right conditions, it happens relatively quickly. The evolution of complex cells took longer. Approximately 2 billion years passed between the origin of life and the appearance of eukaryotic cells. But it happened. The evolution of multicellular life took additional time. But it happened. The evolution of intelligence took additional time. But it happened. At each stage, the evidence suggests that the transition, while not inevitable, is not extraordinarily rare. Life appears to arise when conditions permit. Complexity appears to increase over time. Intelligence appears to be one possible outcome of evolutionary processes. If the early filters were extraordinarily difficult, we would expect the transitions to have taken longer, or to have occurred only once under freakishly improbable conditions. The evidence does not show that pattern. The evidence suggests the early stages are passable, which means the hard part is likely still ahead. The AI analysis identifies several candidate filters in humanity's near future. Nuclear war. The development of nuclear weapons represents, by any measure, the most dramatic increase in destructive capacity in human history. For the first time, a species possesses the ability to destroy itself entirely. The Cuban Missile Crisis of 1962 brought humanity within hours of nuclear exchange. The systems that prevent nuclear war, including deterrence, arms control, and communication between adversaries, are fragile. They have held for 80 years. 80 years is nothing on cosmic timescales. If nuclear-armed civilizations destroy themselves with any significant probability within a few centuries of developing the technology, the Great Filter is explained. Artificial intelligence. The development of artificial intelligence capable of recursive self-improvement represents a potential existential risk that researchers have been warning about for decades. An AI system that becomes sufficiently advanced might pursue goals that are incompatible with human survival. The alignment problem, the challenge of ensuring that AI systems pursue goals that humans actually want, remains unsolved. If advanced AI systems typically destroy or replace their creators, the silence is explained. Biotechnology. The same technologies that allow humans to cure diseases and extend lifespans also allow the creation of pathogens of unprecedented lethality. CRISPR gene editing, synthetic biology, and gain-of-function research are examples. The tools to engineer a pandemic that could destroy civilization are becoming increasingly accessible. If technological civilizations typically destroy themselves through engineered pathogens within a few centuries of developing biotechnology, the silence is explained. Climate and environmental collapse. Technological civilizations, by their nature, consume resources and transform their environments. If the typical trajectory involves depleting planetary resources faster than sustainable alternatives can be developed, civilizations may collapse before achieving spacefaring capability. Resource depletion. The fossil fuels that powered human industrialization are finite. The rare earth elements required for advanced electronics are finite. If a civilization depletes its easily accessible energy and material resources before developing sustainable alternatives, it may be trapped too advanced to return to a pre-industrial state and too depleted to progress to an interstellar one. The AI analysis does not claim certainty about which filter is the primary one. It identifies the pattern. Technological civilizations develop capabilities that can destroy them at approximately the same time. They develop capabilities that could allow them to expand beyond their home planet. The window between developing destructive technology and developing sustainable spacefaring technology is narrow. Most civilizations, the analysis suggests, do not make it through. The dark forest theory adds another dimension. Articulated by Chinese science fiction author Liu Cixin in his three-body problem trilogy, the dark forest theory proposes that the universe is not empty. It is hiding. The logic is game theoretic. Any civilization that reveals its existence risks being destroyed by a more advanced civilization that perceives it as a potential threat. The rational strategy for any civilization that has survived long enough to understand the game is silence. Hide. Do not broadcast. Do not respond to signals. Do not reveal your location. The universe is a dark forest, and every civilization is a hunter moving silently through the trees. Any civilization that makes noise is quickly eliminated. The civilizations that survive are the ones that never announce themselves. If the dark forest theory is correct, the silence is not a mystery. It is policy. The civilizations are there. They are listening. They are not responding because responding would be suicide. And humanity, with its radio broadcasts and its golden records and its deliberate attempts to signal our presence to the cosmos, has been extraordinarily, perhaps fatally, naive. The AI synthesis of these frameworks produces a coherent picture. The great filter and the dark forest are not mutually exclusive. They may both be operating. Civilizations face internal filters, the self-destructive tendencies that arise from the same capabilities that make technological advancement possible. Civilizations that survive their internal filters face external filters, the predatory dynamics of a universe where advanced civilizations eliminate potential competitors. The civilizations that make it through both filters are the ones that never reveal themselves. They expand quietly. They hide their megastructures. They do not broadcast. They survive by being invisible. What we interpret as an empty universe may be a universe full of civilizations that have learned the first rule of survival: silence. Grok AI, when prompted to synthesize these frameworks and identify the most probable explanation for the Fermi Paradox, consistently returns to a combination of these factors. The early filters are likely passable. The late filters are likely severe. Civilizations that survive their internal challenges face external pressures that reward silence and punish visibility. The result is a universe that appears empty to young civilizations like humanity, civilizations that have not yet learned that the silence is not an absence of life, but a survival strategy. The implications for humanity are profound. If the great filter is ahead of us, our priority should be survival. Nuclear disarmament, AI alignment, biosecurity, environmental sustainability. The existential risks that futurists have been warning about are not abstract philosophical concerns. They are the filter. They are what destroys civilizations. They are why the cosmos is silent. If the dark forest theory is correct, our priority should be silence. Stop broadcasting. Stop sending signals. Stop advertising our location to a universe that may be far more dangerous than we have assumed. The optimistic interpretation of the Fermi Paradox, that we are alone, that intelligent life is rare, that humanity is special, is the interpretation that the evidence least supports. The evidence suggests life arises readily. The suggests intelligence evolves. The evidence suggests technological civilizations develop. The evidence suggests they then disappear. The question is not whether we are alone. The question is whether we can avoid the fate that has apparently befallen everyone else. The AI analysis does not provide certainty. No analysis can. The Fermi Paradox remains technically unsolved, but the synthesis of available evidence points in a direction that should concern anyone paying attention. The silence is not an accident. The silence is not a measurement error. The silence is not evidence that we are special. The silence is evidence that something happens to technological civilizations. Something bad. Something that prevents them from filling the galaxy with their descendants. Something that reduces them to the same silence we observe when we point our telescopes at the stars. Grok AI, when asked directly what the most likely explanation is, provides an answer that is as unsettling as it is logical. The most likely explanation is that technological civilizations typically destroy themselves. They develop nuclear weapons and use them. They develop artificial intelligence and lose control of it. They develop biotechnology and release engineered pathogens. They deplete their environments and collapse. They broadcast their existence and are eliminated by civilizations that learned long ago to stay quiet. Some combination of these factors explains the silence. The civilizations are not there because they did not survive. Or they are there, but they are hiding. And they have learned not to respond to the naive signals of young civilizations that have not yet understood the game. The answer to Fermi's question, where is everybody, may be simpler than we want it to be. They are dead, or they are hiding, or both. The dead ones are dead because they failed to navigate the narrow window between developing destructive capabilities and developing the wisdom to survive them. The hiding ones are hiding because they succeeded, and they learned that the universe rewards silence and punishes noise. No matter which explanation turns out to be correct, the conclusion for humanity barely changes. Our greatest mission is not exploration, it is survival. The centuries directly ahead may represent the most dangerous chapter our species has ever faced. Every decision involving nuclear weapons, artificial intelligence, genetic engineering, and the health of our planet is about far more than politics or economics. These are choices that could determine whether human civilization continues or becomes another forgotten chapter in cosmic history. Perhaps that is why the universe appears so quiet. Maybe advanced civilizations never come looking for younger ones. Maybe they stop broadcasting long before they become powerful enough to travel between the stars. Maybe they deliberately avoid building enormous structures that would reveal their existence across the galaxy. Whatever the reason, the silence should not automatically be interpreted as proof that nobody is out there. Instead, it may reveal what happens to civilizations that fail to survive long enough. After comparing decades of scientific research, probability models, and competing theories, many AI-generated analyses arrive at a similar conclusion. They do not argue that intelligent life is impossible. They suggest something far more unsettling, that the universe may be an incredibly hostile place for technological civilizations. In that interpretation, the silence itself becomes the evidence. It delivers a simple message. Every civilization eventually faces a defining test. Some pass it. Many never do. Humanity may now be approaching that same crossroads. Around the world, nuclear stockpiles continue to modernize. Artificial intelligence is advancing at unprecedented speed. Biotechnology is becoming more powerful every year, while environmental pressures continue to grow. These developments promise extraordinary progress, but they also introduce risks unlike anything previous generations had to manage. History has never offered us a guide for challenges of this scale. The real question is whether we can control the technologies we create before they begin controlling our future. Can humanity become one of the rare civilizations capable of surviving its own inventions? Can we build a society that lasts for millions of years instead of collapsing within a few centuries? Artificial intelligence cannot predict that outcome. What it can do is examine the patterns left behind by logic, mathematics, and the scientific evidence currently available. Those patterns repeatedly point toward the same possibility. Civilizations that fail simply vanish. Their signals stop. Their worlds fall silent. Eventually, they leave behind nothing but unanswered questions for anyone who comes after. If that pattern is real, then there are only two possibilities. Either intelligent civilizations disappear before mastering interstellar travel, or the survivors intentionally choose to remain invisible. Both paths lead to the same observation: a silent galaxy. Perhaps the greatest lesson hidden within the Fermi Paradox is not about extraterrestrials at all. Perhaps it is about us. The empty sky forces humanity to confront its own future. It reflects the consequences of our choices long before we ever reach another star. For more than 75 years, scientists have debated Enrico Fermi's famous question. During that time, countless theories have emerged, new discoveries have been made, and our understanding of the universe has expanded dramatically. Yet one fact remains unchanged. The cosmos has never answered. What has changed is our ability to connect information across many scientific disciplines at once. Modern AI systems can compare astronomy, evolutionary biology, physics, game theory, risk analysis, and decades of published research in ways no single researcher could realistically accomplish alone. When those pieces are examined together, one conclusion continues to appear with surprising consistency. The silence cannot simply be ignored. Whether the Great Filter exists exactly as imagined is still unknown. Whether the universe is truly filled with hidden civilizations remains unanswered. But the risks facing technological societies are undeniably real, and humanity is encountering many of them today. That realization transforms the Fermi Paradox from an interesting scientific puzzle into something much more personal. It becomes a warning. Most civilizations, if they exist, may never reach the future they imagined. The challenge before humanity is ensuring we are not one of them. Our destiny will not be decided by distant stars or alien visitors. It will be decided here on Earth, through the technologies we build, the dangers we manage, and the wisdom with which we use our growing power. The future is still unwritten. The universe remains silent. The only question left is whether humanity will someday become another silent world, or the civilization that finally proves the pattern can be broken.